dear students. This is Sonia ma'am and I hope you all are doing well. Today let us discuss some important formulas that we had discussed in the last videos, the derivations that we had discussed, and let us do some numericals and important board questions after discussing the important formulas which we had studied from the last videos. So today let us discuss some formulas of electromotive force. Students, we had discussed what is electromotive force, how we combine the cells in series, parallel and mixed combination, and we had also discussed what is Kirchhoff's law. So as electromotive force, what do we mean by electromotive force of a cell? Students, we had studied that electromotive force is nothing but the amount of work done to take a charge through a circuit, through a complete circuit. The work done to take a charge is nothing but electromotive force. So it is nothing but the potential difference across the circuit. So what is the difference between electromotive force and terminal voltage? We had studied that cells have internal resistances because of which there is a voltage loss, and the circuit has the potential difference always less than the EMF of the cell because of the voltage loss. So we studied that this is the voltage loss because of the internal resistance of the cell, and the voltage or the terminal voltage through the cell across the cell is nothing but EMF of the cell minus the lost voltage. So the terminal voltage is always less than the electromotive force of the cell because of the lost voltage due to the internal resistance of the cell. So we have a graph, and this condition is called discharging, and the graph is always a straight line having a negative slope. So this is what is happening in discharging. If there is no current flowing through the circuit, then it is an open circuit. That means there is no lost voltage, and the EMF of the cell will always be equals to the terminal voltage. Also students, we had studied that during charging, the terminal voltage or the potential difference across the cell will always be greater than the EMF of the cell, and it will be equals to EMF of the cell plus the current and product of current and internal resistance. So the terminal voltage or the voltage across the circuit will always be greater than the EMF of the cell while charging takes place. So we had also discussed the series and parallel and mixed combination of cells. We had discussed in series combination, the current is nothing but equals to the total EMF divided by the total resistance through the circuit, and the total EMF is nothing but total EMF due to all the cells, NE, and the total resistance is equals to the total resistance, internal resistance plus the external resistance. So the current formula is NE by R plus NR. So students, we had discussed when this current will be maximum and when it will be N times the current due to a single cell. It will be maximum, or it will be N times the current due to a single cell when the external resistance is much greater than the total internal resistance due to the cells. Also we discussed in parallel combination that the parallel combination of cells, the EMF across the cell will always be equals to E, that is the EMF of a single cell. That's why the total current is equals to E by total resistance R plus R by N. What is this R by N? This is the total internal resistance of the cells, because each cell has some internal resistance. So the total internal resistance is R by N and the external resistance is capital R. So current flowing will be equals to E by capital R plus R by N. When will this value be maximum or N times the current flowing through single cell? When the total internal resistance will be greater than the external resistance, then the current will be N times due to a single cell. And also we had studied in mixed combination, if there are N cells in series and connected M times, then the total number of cells will be equals to, total number N will be equals to N into M, and current will be equals to total EMF NE divided by the total resistance. And when will this current be maximum? The current will be maximum when the external resistance R will be equals to NR by M, and the maximum resistance will be N by 2 into resistance due to a single cell. So this is the maximum current due to mixed combination of cells. So this is what we had studied in EMF of cell, and then we studied what is Kirchhoff's law in detail and how it is applied in Wheatstone bridge. So let us study Kirchhoff's law also, students. So students, let us study Kirchhoff's law. Kirchhoff's law has two laws. Kirchhoff's KCL law, that is Kirchhoff's current law, and then the Kirchhoff's voltage law, the KVL. From KCL we studied that the total current at any junction will always be zero. That is, the total amount of current entering a junction will always be equals to the total current leaving the junction, and this is in accordance with law of conservation of charges. And the second law, or the KVL, states that the total EMF in a loop inside a circuit will always be equals to the product of current and resistance in the circuit, and it is in accordance with law of conservation of energy. In this case, we had already studied that the sign convention for the current direction, or when we traverse from minus to plus through a EMF, that EMF will be considered positive, and vice versa. Also, we had studied that if current flows through a resistance in this direction, and if we take the direction to be this, and if it is same as that of the direction of current passing through the resistance, then the product of current and resistance will be positive, and vice versa. And using this sign convention in KVL, we could solve complicated circuits by using KVL and KCL. We used KCL, KVL and Wheatstone bridge and derived a balanced condition, the condition at which the current flowing through the galvanometer will be 0. And the balanced condition, or the balanced Wheatstone bridge condition, is P by Q. P by Q equals to S by R, or we can also write P by S equals to Q by R. By using this, we can easily find out the unknown resistance out of the 4 resistances. If we know only 3 resistances and unknown resistance R is to be found, then we can use the balanced Wheatstone bridge condition to find out the unknown resistance from the Wheatstone bridge. So these are the formulas we had these are the concepts we had discussed, and these are the formulas, and using these formulas we can solve some numericals and board questions. So let us start solving some numericals, students. Dear students, let us discuss some important numericals related to electromotive force, combination of cells and Kirchhoff's law. So here we have a question, students. You can see from the figure there are 3 resistors of 3 ohm, 4 ohm and 6 ohm connected in parallel, and current I flows through them, and there is an EMF or a cell of 2 volts and an internal resistance of 2 by 3 ohm. So what do we have to find? We have to find the current drawn from the cell. So we have to find what is this I. To find this, we need to find out, yes, we also have to find current flowing through 3 ohm resistance, that is we have to find I1. So before finding out I1, let us find out I. So to find out I, we need to find out the total resistance due to the combination of these resistors. So let us start, students. We will use what formula to find out the total resistance of this combination? We will use the parallel combination formula. And what is the parallel combination formula? 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So if I substitute the values, what will be the 1 by R1 value? It will be 1 by 3 plus 1 by 4 plus 1 by 6. So students, the value will be 9 by 12. So students, R equivalent will be equals to 12 by 9, which is equals to 4 by 3 ohm. So now we have the equivalent resistance due to the combination of the 3 resistors, and which is equals to 4 by 3 ohm. So now we have the external resistance to be 4 by 3 ohm and the internal resistance to be 2 by 3 ohm. So what is the total resistance of this circuit? The total resistance of the circuit will be R equivalent plus internal resistance of the cell, which is equals to 4 by 3 plus 2 by 3, that is equals to 2 ohm. So the equivalent resistance plus the internal resistance will give the total resistance of the circuit, which is equals to 2 ohm. Let me denote it to be R. So now we know current is nothing but V by R. So we already know what is our V. Our V is nothing but 2 volts and our total resistance is 2 ohm. So 2 by 2 equals to 1 ampere. So the current flowing is 1 ampere. So now students, let us try to find out what is I1. To find out I1, students, we need to find out the potential difference between the resistors. So the potential, let me name them AB. So I need to find out what is the potential difference between AB. So I know I current flows and the potential difference between AB I don't know. But I know the total resistance of the 3 resistors. So V equals to IR using the formula of Ohm's law. So I know how much current is flowing through the 3 resistors, that is I current is flowing, and R is the R equivalent. What is the total resistance of the 3 resistors? I know I also, I know R equivalent, which is equals to 1 into 4 by 3. So current flowing is 1 ampere and R equivalent is 4 by 3 ohms. So here the potential difference between AB will be equals to 4 by 3 volts. Now once I know the total resistance, once I know the total current, I can find out the total potential difference between AB. Now I know the potential difference between AB and I also know what is the resistance of this resistor, which is 3 ohm. So again, using Ohm's law, I can easily find out what is I1. So I can use I1 to be as equals to potential difference between AB divided by the resistance of that resistor. So the potential difference between AB was 4 by 3 and the resistance was 3 for that resistor. So finally I know how much current is flowing through the resistor, and the current flowing through the resistor is 4 by 9 ampere. So this is I1. Similarly, we can find out I2 by using the potential difference VAB and 4 ohm. Similarly, we can find I3 by using potential difference VAB and 6 ohm. So here easily we can find out I2. I2 is nothing but 4 by 3 divided by 4, and this is 4 by 3 divided by 6. So we are using here the potential difference VAB because VAB is common for all the 3 resistors, 3 ohm, 4 ohm and 6 ohm. Let us do the next question, students. So let us discuss a board question, students. So the question says that 3 identical cells of electromotive force 2 volts and internal resistance to be 1 ohm is connected in series to form a battery, and the battery is then connected to a parallel combination of 2 resistors each of 6 ohm. Find out the current flowing through the battery. So let us discuss the numerical. Let us first do the diagram. How many cells are connected? So there are 3 identical cells. So I am connecting 3 identical cells, and there are a combination of resistors each of 6 ohm connected in parallel. So this is how the diagram looks like. So the EMF is 2 volts. Each cell has 2 volts EMF and internal resistance 1 ohm connected to the resistors of resistance 6 ohm. Our target is to find how much current is flowing through the cells, and let me denote it to be I. So students, to find out how much current is flowing through the cell or the circuit, we have to find out the total resistance in the circuit. So we can see here there are 2 parallel combination of resistors and there are 3 resistances in series. So we have to add everything and find out the total resistance of the circuit, and then use Ohm's law to find out how much current is flowing through the circuit. So let me first find out the total equivalent resistance due to the parallel combination of resistors. So 1 by R is equals to 1 by 6 plus 1 by 6, which is equals to 2 by 6, which is equals to 1 by 3. So the resistors have resistance 3 ohm, and each cell has internal resistance 1 ohm. So total resistance will be equals to 3 ohm plus 1 plus 1 plus 1. So we have 6 ohm resistance in the circuit, and the total EMF due to the cell is 2 plus 2 plus 2, which is equals to 6 volts. So the total EMF in series combination will be 6 volts, and the total resistance in the circuit is 6 ohm. So the current flowing through the cell will be total EMF divided by total resistance, which is equals to 6 by 6, which is equals to 1 ampere. So students, let us discuss another question. The question is nothing but the diagram given to us, and we have to calculate R1. So this is the unknown resistance, and this is the diagram which we have to use to find out the resistance R1. So students, here we can see that an EMF of 12 volts and internal resistance 1 ohm is connected to two resistors 8 ohm and R1. The potential difference between R1 is nothing but 3 volts. So the potential difference between R1 is 3 volts. Let me name it VAB. So once we find out how much current is flowing through the circuit, we can easily use Ohm's law and find out what is R1. So students, this is 3 volts and this is 12 volts and this is 1 ohm. So, and this is 8 ohm. So the current flowing through the circuit will pass through 8 ohm and R1 also. So let us try to solve this. So students, total current in the circuit will be equals to total EMF E divided by total resistance, and the total resistance in the circuit will be 1 ohm plus 8 ohm plus R1. So the total EMF of the cell will be equals to 12 volts. So using 12 divided by 9 plus R1. Now students, the voltage between AB is 3 volts. So we can use I into R1 is equals to 3 volts. So we have two equations here. From here easily I can find out what is my I. I is nothing but 3 by R1, and substitute this value in this equation. So we have 3 by R1 is equals to 12 by 9 plus R1. So we cross multiply. 12 R1 is equals to 27 plus 3 R1 implies 9 R1 is equals to 27, or R1 is equals to 3 ohm. So students, this is a very easy way to solve this diagram. First we need to write what is the total current flowing by taking all the resistances and the EMF of the cell, and then we take help of this potential difference across R1 and use Ohm's law and write the equation and substitute. We substitute I value into this equation number 1. So once we substitute this I value in equation number 1 using equation 2 in equation 1, we get an equation for R1. Solving that equation, we can easily find out the the desired resistance to be 3 ohms. Let us solve another board question, students. We have to use Kirchhoff's law to find out current I1 and I2 in the given circuit diagram. So there are two EMFs, 34 volts and 10 volts. 34 volt has internal resistance 1 ohm. 10 volt has internal resistance 2 ohm. And there are some external resistances connected in the circuit. So here there are two loops, and as we know, we can use two loop law, that is Kirchhoff's law, second law, to solve the loop equations. So students, here you can see in the first loop I1 current flows, and here in the second loop I2 current flows. and at junction B we can see I1 and I2 to be meeting. That means this current will be equals to I1 plus I2. So the current flowing through 5 ohm resistance will be I1 plus I2. So let us first see what current flows through what resistance. I1 current flows through 7 ohm resistance, through the e.m.f 1 through 4 ohm resistance. I1 plus I2 flows through 5 ohm resistance. Similarly, I2 current flows through 7 ohm resistance, second EMF, and also 4 ohm resistance. So let me take this first loop and try to write the equation using the KVL law, that is summation E equals to summation IR, and we know the sign conventions for that. The sign conventions for voltage law is that if EMF current is passing from negative to positive terminal through the cell, it should be positive, and if product of current and resistance is positive, that means the direction that we have traversed and the current direction are same. So let me take this direction. So I am taking a counterclockwise direction for loop 1. So for loop 1, let me write down the KVL equation. So let me write down the total EMF in the loop 1. There is only one EMF in loop 1, and that too the direction that we have taken is from negative to positive for the EMF. That's why the EMF will be positive. So 34 is equals to, so what are the resistances in loop 1? 1 ohm resistance, and current is flowing in this direction, and the direction that we have traversed is also same. So 1 into I1. Also the current flowing through 4 ohm and the direction that we have traversed is same. So 4 into I1 plus the direction that I have traversed and the direction of current flowing through 5 ohm is also same. So I1 plus I2 into 5. Similarly, the same direction for 7 ohm resistance. So the product of current and resistance will be same. That is 7 into I1. This is my equation number 1 from loop 1. So let me just separate the values and add them up and write. So 34 is equals to 5I1 plus 7I1 is 12I1 plus 5, that is 17I1 plus 5I2 is my equation number 1. Let me not write this as equation 1. So 34 is equals to 17I1 plus 5I2. We got it from loop 1. So now let me take loop 2 and let me try to take clockwise direction. So we can see that if I go clockwise in this direction, the current is, the direction that we have taken is from negative to positive of the EMF. So this EMF will be positive for the second loop. So 10 is equals to, now let us take the current and resistance product. So as I go in this direction, the current and the direction that I have taken is same. So 2 into I2. Similarly, it is same for 4 ohm resistance. So 4 into I2. It is same for 5 ohm resistance. So 5 into I1 plus I2, because I1 plus I2 current flows through 5 ohm resistance. Similarly, 7 into I2. So all the resistances are positive here because the direction that we have traversed and the direction of current is same in this second loop also. So let me write it down. 10 is equals to 2 plus 4 is 6. 6 plus 5 is 11. 11 plus 7 is 18 I2. And we have 5 I1. So this is my equation number 2. Solving this equation 1 and equation 2 simultaneously, we can easily find out the value of current I1 and we can find out the value of current I2 in the given circuit. So students, solving for I1, I2, we get I2 to be 0 and I1 to be 2 ampere. So this is how to solve Kirchhoff's law by using KVL and KCL. So students, in the next video we will discuss some more important board questions. Till then, please solve some numericals from your textbook. Thank you so much, students.